So hello everyone. In this video, I will discuss one more famous interview questions. That is the end or implementation of the 2 cross 1 mux. Means how can we design the 2 cross 1 mux using the or gate. And finally, this figure we need to convert into the 2 input NAND implementation. Means how can we design using the NAND gate only. I already explained the NAND and NOR are the universal logic gate. So one of my friend is there. So this question was asked in the STMI electronics. You know already about this is the good village company STMI electronics company. Okay. So so we start these questions. So finally, the about the 2 cross 1 marks I already explained. So this time I am telling. Okay, so this is the 2 cross 1 marks. Okay, na? So I am explaining this how can be done. So firstly, I am explaining the part 1 answer. Part 1. Okay, so this is the 2 cross 1 marks. Okay, if this is the 2 cross 1 marks is there, so two input line is there and one selection line will be there. Okay, so the two input line I am assuming this is the 0 and 1, means this is the I0 and this is the I1. Okay, this is the two input line and this is the output, and the selection line I am considering that is the S. Okay, so output equation how can we write? S complement into I0 plus S into I1. So this is the output equation of 2 cross 1 marks. Okay. So this thing I need to design using the and or gate. First part. See what is the and or implementation, means AOI implementation of the 2 cross 1 marks. So this is the very easy. How can we design using the two input? Means and or gate. This is the very simple. So this is the inverter. So firstly, here I will make inverter. Okay, this is the S and this is the S bar. Okay, then so this is the, and here I will make, and this is the AND gate. So this is the I0, this is the I0, and finally so one more AND gate we will need. Because of that, this is the I1 into S, but here I will copy S as it. So this S and this is the I1. Okay, I hope you understand. This is the very simple diagram, and this is the OR gate. So this is the very simple thing. Because of this is the S bar, this is the AND gate, no? This is the AND gate, this is the AND gate, and this is the OR gate. Okay, so S bar into I0, and this is the S into I1. So finally, here you can add this same expression. We will get S complement I0 plus S into I1. I hope you understand. This is the AND gate and this is also AND gate. Okay, so this is the AND OR implementation. This is the AND OR implementation of the 2 cross 1 marks. Okay, the 2 cross 1 marks. So this is the part 1, but in the next part I need to design this thing using the two input NAND only. So how can we convert into the NAND only? So one thing I already explained. What? See, to make the one inverter, the how many NAND gate we needed? Make one inverter means one not gate, this thing I already explained. One not gate we need only one NAND. Okay, only one NAND we need. Okay, and one AND gate, how many NAND gate is needed? Two NAND gate. Okay, I already explained in the previous part. You can see in this playlist. Okay, and one OR gate, If you want to design one OR gate, how many the NAND gate will need? uh, Means 3 NAND gate. Okay, so now I will design the same figure. I am going to convert using the NAND gate. So firstly, inverter is there. So how can we design the inverter using NAND gate? Yeah, so this is, I hope you understand. Okay, so this is the S and S bar. Okay, and this thing. Okay, here the one AND gate is there. So to design one AND gate, how many NAND gate is required? Two NAND gate. So here I will connect the two NAND gate. This is the two NAND gate. I hope you understand. Okay. Then again here one NAND gate is there in the figure, previous figure. So I will replace here the two NAND gate. Because of that, to make one AND gate, we need the two NAND gate. Okay, the final figure I will make also, no problem. This is the I0, and this thing I explain like that. This is the S, and this is the I1. Okay, and finally I told, I explained to make one OR gate, how many NAND gate is needed? 3 NAND gate. So here I will convert the 3 NAND gate. See, I am changing color. Okay, so this is the complete one OR gate. Okay, in the output this is the one OR gate. Okay, and this thing is the AND gate. This thing is the AND gate, and this is the NOT gate. And one thing so this is not a complete figure. One thing I am explaining, if 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 the two inverter will come into the series, that is the one inverter and one inverter, then this complete inverter will replace as a short circuit. How I am telling, if you place at the input 1, how much it will come? 0. Because of that, this is the NOT gate. 1 0, and then it will come 1. So so here you provide 1, and at the output you are getting 1. So this complete circuit is replaced as a short circuit. So one thing I am concluding, if the two inverter will come in the series, it will replace as a short circuit. So this is the two inverter, means one NAND gate here. The means NAND gate be used to design the inverter, no? So these two inverter replace as a short circuit, and these two inverter also replace as a short circuit. So final circuit I am making, this is the very famous interview questions, and this way if you explain, interviewer will very happy. Okay, so this thing, this is the S, this is the I0. I am changing the color. Okay, so because of this is short circuit means complete path. If the two inverter will come into the series, we can replace as a short circuit line. Okay, so and also this figure, because of this so this thing, and at the output will connect. So how many NAND gate is needed? Only the 4 NAND gate. Because of that, we need to convert into the minimize. How many minimum number of two input NAND gate is required? Okay, this is the thing important. So this is the S, and this is the I1. So you can say this is the S bar. No need to write this thing. No problem. If I write, okay, no issue. So this thing and I1, and this is the NAND gate. So this is the AND OR implementation. Here you can write S complement I0 plus S into I1. So this is the complete. So this is the answer of part 2 questions. So this is the only the this is the only NAND two input NAND implementation of the 2 cross 1 mark. This is the famous interview question. How many NAND gate is required? Only 4 NAND gate. Means minimum number of NAND gate is required. because of this thing is replaced as a short circuit, so only this NAND gate and this NAND gate is left, this NAND gate and this NAND gate, and in the bottom this is the short circuit, only this NAND, and at the output NAND. So how many NAND gate is needed? Only 4 NAND gate. I hope you understand. So this is the this questions is very famous interview questions, and so thank you guys. In the next video we will meet, and bye.